confusion here. Let me share this. So back to what I mean by JFrog unified approach. It's basically provides you an end-to-end platform capability, all the way from visibility, governance, and control. Every artifact that's uploaded onto this JFrog platform gets a continuous security, not just the vulnerability scanning, but also license compliance issue and a whole lot more with JFrog advanced security play. We look at contextual analysis, secret detections, malicious package detection, and so on and so forth. So the continuous security gives ability to manage the life cycle of an artifact from a security perspective. And again, scale to infinity. The Artifactory does scale pretty well, all the way from hybrid to multi-cloud and everything in between. And radically universal, meaning 30 plus package types and counting every new package manager getting added so often. And also 50 plus partners in terms of integrated approach on how do we integrate with majority of the DevSecOps tool in the market. Again, at the center of our platform here is the JFrog Artifactory, which stores and manages the software lifecycle and the container images. So built around it is JFrog. JFrog Artifactory is supported by what we call as JFrog X-Ray, which provides a security and compliance issues security scanner and focuses on supply chain security. I'm going to talk about that here in a minute. The JFrog pipeline is CI/CD solution for automation and orchestration of this platform. And mission control and insights provides you an ability to manage day-to-day operations in terms of managing multiple Artifactory JFrog platform deployments. And again, distribution is at the core of managing how do we securely distribute the piece of software from one data center to another data center, or between Artifactory instances or Artifactory instances to what we call as edge devices. And JFrog Connect is something that will provide you an ability to manage your edge IoT devices. Anyway, all the way from source code repository to pushing your artifact to the runtime onto the public cloud or on-premises or regional cloud, we have an ability to provide you and standard, pretty much uniform integration APIs across the services, right? And again, the core premises of this today's presentation is all about what we call a software supply chain. And again, software supply chain is composed of components, library, tools, and processes, right? That is used to develop, build and publish software artifact. And how do we do that, right? So the way we look at this is you have a bunch of developers that are on task to build a mission critical application, store their code in public repos, and then they have to basically to store the piece of software that they built. And again, the way they are building it using configurations or secret, and then upon building the piece of software, they basically release the piece of software to the end customers, right? And then they distribute to a plethora of devices like IoT, distributed edge, or public cloud, or on-premises and hybrid. And again, this software development lifecycle is nothing new, but what is new is what we call as the visibility and the control, right? The visibility and monitoring the flow of at every phase of all the way from developing to storing to building, releasing, and distribute makes it more interesting in terms of what we have to do. Again, the thing that I wanted to actually quickly highlight upon based on the platform services around is JFrog X-Ray, right? So JFrog X-Ray provides you a security integrated into the CI and CD. The way we do this is looking at this artifact every time a new artifact or a new build or a new release bundle, which is the primordial concept in distributing what we call as a release bundle that consists of your build, a released artifact, metadata, configuration, and so on and so forth, what we call as a release bundle. is the release bundle is the one that gets distributed across the Artifactory instances. Again, X-ray kind of kicks in and then does what we call as a scanning, the piece of software or an artifact that gets checked in into the Artifactory. And how it does it is by what we call as a policy engine that that the policies get evaluated. And if there is any critical violation or a minor violation based on that, one could take an automatic action in terms of preventing a build or failing a build or blocking the distribution, right? Again, you can also notify a variety of users or email or Slack notification and things like that. And one of the recently added X-ray features is around enhancing the CVE data and also malicious package detection. So what this means is if you historically consider, let's say, considering Python packages, right? So you go to PyPy, centralized repositories often delete or completely take out the malicious packages, right? And what JFrog has done here in terms of detection is we have basically curated our database with some of this malicious package detection or findings by JFrog security team and the history associated with it. In that way, you don't have to depend on a centralized, repository to provide you the historical information on when that package was detected or when the malicious things was detected in a package and what they did and so on and so forth. So that part is added into the X-ray. And then also from a operational risk policies, what I mean by this is, pretty often a lot of open source or any piece of software, open source libraries are stored on a public repos. And then most of the time, developers, in order to get the developer velocity going and trying to get something working, they would download a piece of software from a repository that could potentially be an operational risk. What I mean by this is JFrog platform X-ray will alert you whether it is high or medium or low risk based on certain parameters, like how many number of commits have been done in last 1 year, or how many releases are being put out, how many committers. And again, that parameters of calculating the risk score is getting added or getting improved on as we speak in terms of how many branches and what got committed to the main branch and things like that. So we are looking at those things to tell you, look, you're downloading a piece of software from a stale repository which hasn't been updated or actively maintained. And again, one of the critical things that we have added to X-ray is what we call as industry, standard SBOM, right? Software Bill of Materials, which basically is all about SBOM generator. We have an ability to mark your artifact with vulnerabilities, right? Like not just a CVE, but also license compliance issue, and you can version it and you can export it to industry standard formats such as Cyclone DX or SPDX. And again, most of our DevOps tooling integration into Jira integration is provided as a first-class support here. Again, why are we talking about all this? We are talking, the reason I'm setting all this context is how do we bring a piece of software from outside world for your development purposes, and how do you curate it using secure policies with your SecOps personas and SecOps policies that you want to implement before actually handing that piece of software to the developer for them to build an application. And again, one of the things that we are working towards is what we call as a zero trust verification with what we call as an end-to-end binary lifecycle management. So I'm going to talk about what exactly this means. I'm going to come back and talk about what Matthew is asking about NPM package here in a minute. Think about there are disjoint teams, right? Like you have, even though we call it as DevSecOps, and these terms have been floating around for some time, but in reality, there are a lot of verticals such as security, development, operations, and SREs. They are all operate in their own silos. And now since SBOM is here, this is almost like 2 years since this White House has, executive order on software bill of material is out as of May 2021. But one of the things that we absolutely have to take in control is what is our visibility, right, in terms of awareness of risk. So if the platform provides you an ability to complete visibility to every piece of software and its dependency to the nth level, then you're more aware of risk in terms of what you're bringing to the platform, right? And again, zero trust is here. And then the way we are looking at this is think about a DevOps persona, right? You have a developers who's using their CI of their choice, and then we have the repository, what we call as a write repository, where the developer is going to look for a piece of software that they want to use in order to build their application. Again, there is also a SecOps, persona, or a security team who is actually building what the security policies looks like, right? And they could basically stand up what we call as an open repository. And again, it's color coded here to distinguish between what's closed and what is open, and what is right and what is open repository. And again, this repository, please pay attention that this is open to the internet, meaning it has access to the internet so that it can go and download the piece of software. And again, when the developer requests the piece of software, the flow, actually the request flows into this open repository, usually stood up in, let's say, like a DMZ environment, and a DMZ environment, and then they could basically download the piece of software from internet, and then have X-ray scan it using the SecOps policies built by your security team. And if they approve the policy, then the piece of software will be federated or transferred back to this right repository so that your developers can start using it. So this is what we call as a self-curation process. And this is the premises of today's discussion in terms of what we need to do in terms of this workflow, and my colleague Daniel will focus on. And again, once the piece of artifact which is curated flows back to the right repository, you have we can generate an SBOM, and again, this is what we call as a shift left. And then once the mission application is built, and you could basically promote that to what we call as a read repositories, which you can think about this as like Artifactory edge node, where it could be consumed or distributed from this edge node to a variety of runtime, right? And again, the self-service distribution process, which takes care of compliance and admission processes, is what we call as a ship right. And again, this flow of left-hand side is what we're going to talk about today with respect to this, what we call as a self-service curation process in a non-air-gapped environment. Again, we are going to do this as a two-part series. The next webinar sometime next month will be focusing completely on this right repository running inside an air-gapped, and what's the workflow associated with respect to what the product provides today with respect to curation, and some of the workflow that our team has implemented in terms of what needs to be done. Okay, so with that, I'm going to stop sharing my screen and hand this over to Daniel to take this forward.
Thank you. Let me jump over here real quick. Let's do the screen first. And then Share screen. Share. Okay. Can everyone see?
Yes, we can see your slides.
Okay. So thank you, Sudindra. From here, we'll get into a little bit more of the nitty-gritty technical side of what we're doing in this webinar. I'm going to go over a quick overview of what we're trying to accomplish in this and in part two. Talk a little bit about what we'll cover today, go into more detail about what curation is. There's 3 or 4 layers to that. Talk about the components we're going to use, and then demo the part 1 that I have set up. So the overall thing we're trying to achieve in this particular webinar is to set up a curation environment that allows for bringing packages from open source on the web into an environment, filtering them, and then passing them through an air gap, in particular, like a high security, low security style air gap into a high security environment so they can be used for developing in a secure area. One of the pieces of this is that air gap is a physical air gap, not just a like subnet air gap or anything like that. And the plan here is to build up over this and over the next part that this entire platform, so that way we can carry these artifacts into the secure environment and then have them be used so developers in that secure environment can continue developing, knowing that they can bring in open source packages, have them scanned, have them curated, have them make sure they're safe, and then move them into the secure environment and be able to use them. What we'll be covering today is, in this diagram, is the right side. In particular, the curation workflow piece. We need to set this piece up. We need to show it working, and we need to understand what it's doing and how it's put together, because this is the key piece of curation. This is the curation workflow. Everything else around it is moving the packages around. So a question that comes up is, what exactly is curation? Lately, we've been talking a lot here at JFrog, talking a lot about curation. And I've noticed, others have noticed, that curation is one of those terms that gets thrown around a lot. A lot of people have different ideas of what it is. So what I want to talk about today is curation as I'm going to work through it. The curation workflow, let's jump down to here and focus just on this piece. This curation workflow, in particular, is the idea that a developer needs to request a particular dependency from open source. And then there should be something that that developer can request that dependency through that will go out, get that dependency from open source, bring it in, make sure it's safe, and then make it available to the developer, and do this all in a fairly automated fashion. I say fairly because there's always pieces that are either hard or impossible to automate, e.g. the air gap. But this overall process, a lot of times we'll refer to the curation process and the curation workflow. And there's a lot of pieces that can come into this that a lot of the people we talk to may not think about. Depending on the business processes around how this curation is supposed to happen can greatly affect the curation process. In a company like a small startup, the curation process may be something as simple as configure your package manager to point to Artifactory, and Artifactory handles it, and then you can pull it down when it's done, when it's available, once it's blessed by Artifactory and X-Ray and our curation product. Other times, especially with some of our larger financial type customers, they don't want that to be automatic. They want process wrapped around it. So with one of the customers I'm working with, we've been setting up a process where the developer can't just pull it. The developer has to put in a request into a ticketing system. Think something like ServiceNow. Then that request goes in that ticketing system. It gets checked automatically to see, is all the information here? If yes, it triggers a pipeline that runs the actual steps of the curation process on Artifactory. Then, depending on pass or fail, it'll return the results back to the ticketing system. And based on that pass or fail, the ticketing system can then make a decision on whether to just send back a, hey, everything's good, developer, go pull your stuff, or send it to a secondary workflow where it hands off to a security team and they go do a manual evaluation on that package and possibly rerun the process. Or we know this package, we know it fails, we've already vetoed it, just send a result back to the developer saying, hey, you can't use that package. So there's all of that extra process that comes around or into curation. Now, Surinder talked a lot about X-Ray, and X-Ray is our primary security tool. We also have, focusing on this particular curation piece, we have a curation product coming out. And in the next quarter or so. And this curation product, I'll show a little bit more of exactly where it fits in a minute. But the big difference between using X-Ray to scan everything and the curation product itself is the curation product is going to filter things before you pull the dependency into Artifactory. So in the diagram I have here, we would process the dependencies, we would pull the dependencies into, I call it a curation remote in this diagram, but it's a remote repository on Artifactory. And then X-Ray scans those and then makes them available to the developer if they pass, or blocks downloads if they don't pass. Curation gets put in front of that, in that the curation product and a second product called Catalog that works with curation will provide all of the data for basically being able to determine if that should even be pulled down. Example would be, say, Log4j, right? There's the big Log4j issue, the big remote code execution issue a year or two ago now. And X-Ray can detect that, but it has to pull whatever it is down, check and make sure there's Log4j in it, in those versions that are incompatible, and then block it. Curation would say, hey, I know looking in this catalog of pre-scanned packages, we know these packages use that particular version of Log4j. So before even trying to pull them down, the curation product will say, no, we're just going to block that one outright. And then you don't even have to pull it into your environment. The X-Ray would then be the second layer of security in this particular case, where if something got pulled in because it passed curation, or it was in a private repository from a vendor that curation couldn't really handle because curation's focused on open source public, X-Ray could then scan it, make that determination. So that's the curation product and how it fits into the curation overall process or workflow. There are, I don't have a good slide for this, but there are 3 overall methods of how to work with the curation process. And I mentioned 2 of them earlier on. The first is a developer can do a pull through. So that would be the developers working, run, say, Maven build or PyPy install or Docker pull. It goes to Artifactory. Artifactory tries to pull those remote artifacts, scans them on the fly, and then pass or fails them, and then sends an error straight back to the developer. The second method, we're still coming up for a good name for this, but I call it gated or a batch process. And the idea there is what I was talking about earlier around the bigger process with some of our financial customers, where you can't just pull it, you have to put in a request. The request then goes and runs through a pipeline that does all the dependency tracking, pulls everything, scans everything, combines all the results, and then possibly triggers more. And then the third method is the one we're eventually going to end up at the end of part 2 with here, is the full air gaps. And the reason I separate this one out is because it builds on the previous one, but then adds in a bunch of extra process around bundling up all the artifacts and then getting them back into the secure environment, so that way they can be used in that secure environment. So the last thing I want to touch on in the talking about this, the demo I'm going to be running today is going to be 2 environments. There's going to be the low side environment and the high, and we're not actually going to touch the high side secure environment, but we'll have it there. This process is scalable from 20 or 30 developers sitting in an office with a low side and a high side environment and kind of everything running on those 2 environments. Scalable all the way up to massive enterprise level deployments. Jumping back to one of Sudhindra's slides here, this 4-tier diagram. Loading. So this is a diagram we use to talk about some of a large enterprise where you have multiple JFrog clusters running in each of these tiers. And we have these tiers separated out by duty, by the responsibility. So in this case, the curation would happen over on the left in the pink tier, and then most of your development happens on the yellow. In our small 2 environment, all of this happens on each tier. In our large enterprise, each of those responsibilities are broken out to different levels. And so you would have this whole thing running in your low side, and then you could also have a yellow, a blue, and a red tier. So your dev, your production, and your deployment or distribution all running in the high side also. And then this air gap piece would then get things from the low side to the high side, basically from your low side yellow and pink into your high side yellow, and it still handles all of the security and it's completely scalable. More details about that, we can set up meetings to work through your specific use cases and look at your scale and show how to do it. Today, we're just going to have 2 environments to keep the demo simple. Now, the components we're going to use today in doing this are, let's use the marker. All right, so first of all, we're going to use JFrog Artifactory. That's the core of our platform. That's where the repositories are. That's where everything else connects to. We're going to use JFrog X-Ray. This does the security scanning. When Curation product is released, it will sit next to X-Ray and help in that same role of making sure the artifacts are safe before they come in. We're going to use pipelines today. Again, showing that gated batch process. And then not today, but in part 2, we'll be using distribution to show how to get artifacts across the air gap. All right, let's get out of here. Annotate, clear. All right, so jumping over to excuse me. All right, jumping over to, this is the environment I mentioned we'll be looking at today. So I have a number of repositories. I'm going to walk through how I have all these pieces set up. today, and then we're going to run them and show what's going on. So start off, here is the administration panel for repositories. I've created a number of repositories here. I called them scan, just so that way they were easily identified. And then we at JFrog tend to use some name, the type, and local for local, remote for remote, just to help delineate in our demo environments. This naming scheme is entirely up to you. So you see Docker, Maven, NPM, PyPy, RPM. Today, I'll be working with PyPy. But so these are scan local repositories. And then these are the remote repositories I've set up. So you can see here, this is an RPM type repo that points to the public CentOS. This is one for Docker that points to Docker Hub. This is one for Maven that points to Maven Central. And this is one for PyPy that points to Python hosted, the main PyPy repository. So if we go in here and look, for the pull-through method, we use these remote repositories directly. So in this case, you can see I have it set up pointed to Python hosted. And a key piece here is you have to have enable indexing and X-ray enabled. And that's what triggers X-ray scanning. There's a couple more pieces in X-ray, settings in X-ray. I'll walk through those in just a minute. But that's the big piece, is make your remote for the pull-through method, set up X-ray, so X-ray is active. If there's any other settings, you can set those in here. There was a question about setting up NPM to use Artifactory. So I'll just go touch on that real quick. If I come down to my NPM repo, this view is the user view. I jumped out of admin. So scan NPM local. If you go to set me up here, it actually brings up the settings here that show how to configure NPM. So you can, and it'll actually fill in like scanned NPM local. So this right here can show you how to do it, or and it'll do it for just about every repo type we support. Here's how you set up your main package manager, in this case, NPM. So I just wanted to touch on that so you can see that. Jumping back. So we're going to go to X-ray, watches and policies. So for those of you that haven't seen our X-ray implementation before, there's 3 pieces to building up. Basically building up, we generally call it the policies in X-ray. There are watches, which apply policies to repositories or to projects. There are the policies themselves, and then there are the rules. And the policies fall into 3 different categories: security, operational risk, or licensing. The rules can then be put on the policies, and those rules have lots of different options for them. So this is looking at a rule for a security policy. So I have it set to look for vulnerabilities with a severity of high. Now you can set it to malicious packages, exposures if I had the advanced security active, which I don't in this demo environment. So we use vulnerabilities and we'll set it to high, but you could set it on CVSS score. You could set it to specific vulnerability IDs. And then there's a bunch of options on what you can do. For what we're doing today, the key here is to enable this block download and block unscanned artifacts and block release bundle distribution. These 3 options will prevent anything being pulled in from, if it has any kind of vulnerability, if it has any kind of issue, it will prevent it from being downloaded, which means the developer can't pull it. And this is the key piece, and you have to put it on every single rule. So if that rule's triggered, it blocks the artifact. And the reason for that is these rules can have different things. So say you wanted a rule with high severity vulnerabilities that just blocked everything, but then you wanted one with medium severity vulnerabilities that didn't necessarily block, but it might notify somebody, either trigger a ticket into a system or notify the security team or something like that, that, hey, somebody got something that's a little questionable, but not bad enough to block. So that's why these are on the rules. But you have to set those, and you have to do it on every single rule. We add rules to the policies, and then jumping back up to the watches. So I've got one here for security and one for operational risk. We create watches. So in this case, I have one for filtering remotes, and we have to set what remote repositories we want this on. I have it set to any repository, locals, remotes, whatever, any high level or critical level vulnerability, just block it. Block the download, don't let it go anywhere. Starting point, again, for a demo environment, you could get very, very complex with all of these policies and have different watches with different policies for different teams with different requirements. All of that can be put into here. You can do it based on builds and based on bundles. Like I said, we'll poke a little bit more at the bundle side of thing next part when we're working with distribution. And then you set it which policies you want. So manage policies, add the policies. So I added these two. So that's how we set X-ray up. For the pull-through method, those are the two key pieces here using X-ray. Again, once the curation product comes out next quarter, then there will be a setting on the remote repository to enable curation, which will then do curation and then X-ray. So they'll work hand in hand. But that's how we set that up. So now, let me check something real quick. It's processing the data. So I bet this is actually going to block, but we'll give it a try. All right, let's go to, come on UI, artifacts. So I will be pulling from this Python hosted PyPy remote for this pull through demo, the Python hosted PyPy remote cache. So this remote doesn't actually store much in the way of any data. There's just references here. For anything that's cached, this remote cache is specifically what actually stores it. So if we go down here, I can show I've been pulling the Flask package. We'll go to X-ray. All right. Let me reset my share. I just need to share the whole screen. All right. So we can see here, if you can see the terminal, I have my pip configured, my Python configured to pull from my environment. I tried pulling Flask. While that download was processing, X-ray did not let me download this Flask package. It didn't have the info. It couldn't complete the scan. Now it's showing that the scan is complete, so I should be able to pip install Flask. And now we're going to see, all right, it got Flask, but now it's pulling the Wurzug, and now it's going through the scan process. So if we come back here, and Zoom windows are always in the way. We'll just refresh it the hard way. So if I come back here now, we can see there's another package coming in. Wurzug, go to X-ray. scan is in progress. And if we go back to the terminal, you can see we're waiting until that scan completes. And this will go either until it hits pips timeout and you have to try again, or until the scan completes and then it will continue. So this is the pull through method. We can see it'll block things sitting here until it pulls through, and eventually it'll succeed, or it'll outright fail with a, in this case, in the case of something is outright blocked due to a violation, it will actually fail with a 403 as opposed to a timeout. We are working on making this messaging a little better, but it's really hard because this messaging specifically is from the PyPy or the pip tool. We can only provide like the error message back. So it's a little ugly, but it's something that at least tools can process if you know what to look for. So this is the basics of a pull through curation. Again, we'll go through more packages in the future. I'll demo more packages in the future and just in here in a few minutes. But so this is the basics, right? If the scan fails or the scan is still in progress, block the package. Once the scan succeeds, allow the developer to download it. Pull through curation method. The taking it to that next step, the gated or batch method, I bring in a pipeline. So if I go over here to pipelines, so here I have a pipeline, I called it gated PyPy. And it runs a step, and it should be a failed step. It runs an error because of a typo. I will talk through what it's supposed to do, and then I will fix that for the next part. So what it's supposed to do, if we go here, is it's just a simple Python script that goes through and it pulls some packages. So again, we have a webhook come in. So we go get a payload. We then run through each of the packages. In fact, we run a PyPy command. So it's going to be up here. So we go get the payload. We separate it into a list of pieces, basically each item. And we go through and we do the dependency resolution. And then for each of those dependencies, we build a list. We go through and here we go. No, let's curate. So we go through and we pull those packages one by one after we do the download. So we dependency resolve, and then we pull each package one by one. And then based on the output, if it downloads successfully or if it fails to download, we bring those into a list. In this case, if it successfully downloads the package, then it will, in this case, copy it into a local repository and then return the results back. In this case, I just have it printing the results back. So if we go back to here, the idea being, I wish I didn't have a typo in the script. The idea being, so we would attempt to download them from this Python hosted PyPy. If it's all successful, it would copy them into the scanned PyPy local. And then the packages would be there, and then they would be available in this local repository. And that does a couple of things. Number one, the cache for the remotes goes away after a certain amount of time. So after whatever the configuration is, 60 days, 90 days, to save space, the cache will slowly get purged to clean up after itself. A local repository does not clean up after itself. It will keep everything until you specifically go run a process to clean it up. The other thing is having the developer pull from the local breaks the pull through. So any developer pulling from a local, if the package isn't there, they just get a 404. Whereas if they pull from a remote, it triggers and tries to go out to the curation. Well, it tries to go out to the public, pull it through the curation and through the X-ray, and then bring it into the developer. So if you have higher security requirements about what could be in, you need to just say outright no to this type of package or this series of packages or this developer. You can set it up the developers, your local developers pulling from the local, and then your process has all that extra information in the pipeline that will then filter all of those packages on things above and beyond X-rays, vulnerabilities, X-rays, licensing, and the curation products, policies on licensing and known vulnerabilities. You can add other things in, like, I know in the past I've worked with companies that said, can't do anything with Spring, right? No Spring comes in the company. So that would be something that they could add in the pipeline. And then the developer pulls from the local, the developer won't automatically trigger, go and pull it from open source and try and curate it. It has that internal air gap in Artifactory that prevents that jump. So I was going to show the pipeline, but I guess I broke it right before the demo. Oops. Are there any questions at this point? I see a couple in the Q&A. Are there any that I should address on screen?
So HemB has a question. If we block the open source module in policy and the scan is taking longer, build may delay, how can we check if the scan is going through properly from Artifactory UI?
Okay, there's a couple of different ways. You saw me check on here by going to the package. If you know which package it is, you can look at the X-ray tab on the package and it'll show the status. You can also look through in the X-ray scan list, and this will show what repositories have things that have been scanned. In this case, we see the PyPy remote cache has one indexed artifact. We know there should be a second one in there. We know this scan is taking a while. Just on a side note, there's a lot of really good information here. I'll touch on that in part 2. I know for a fact the scan is taking a long time because this database sync is hung up. It's processing. This is about 150 to 200 gigs of data, and I mistakenly hit update right like 2 hours ago, thinking it would be done by now. So this is actually what's hanging up that scan right now. So that's where you can also go into settings, and you can see in indexed resources, this has information about, I have one of 2 scanned, and then this is where you can go in and force an index now. You can update the status. You can also configure information retention. So X-ray only holds information for a certain amount of time. Really, this indexed resources is like from the administrator side, where you can see if this index status is perpetually hung, all right, something's going on, you need to go to the logs for X-ray. The X-ray logs on a self-hosted environment like I have can be found under monitoring system logs. And then we can go up to X-ray and we can see everything that's going on. So there's a number of messages in here, basically saying that it's busy, it's working on things, it's busy. It's not this execution service not available because it's not processing for that scan update. But you can come here to the logs and you can see if you're on the SaaS environment for this, then you would have to request the system logs from our support department. The system logs is not available on SaaS, but generally with this air gap, 99 times out of 100, you'll be on a self-hosted environment because you're going to be going through all the security lockdown, making sure everything's staying within your borders, within your firewalls and all that kind of stuff. So those are the areas where you can find more information about what's going on in X-ray. One more, just for a little bit higher level view, since I'm not hearing any other questions jump in. If you go to this service status, you can see the status of all the actual services for each of the, or all of the actual processes for each of the overall services. So like if X-ray is just down, you'll get flags here saying something's unhealthy, or it'll actually up here, it'll say, this will drop down and say the whole node is offline, things like that. There's a lot of status information in here. Any other questions?
I think we're good. We can just go ahead and wrap up the presentation.
Sounds good. I think the last slide we have is just the thank you slide at this point. Like I say, in part 2, we'll be building on this. I'll fix the bug in my pipeline. And then we'll build on this. We'll show the full air gap, and we'll show how we get those packages, the requests out of the high side into the low side, and then the packages back into the high side in a secure air gapped fashion. We're even going to do it in such a way that you can carry it through a man trap if needed. So thank you.
Yes, thank you. So for everyone, just an FYI, part 2 of this webinar series will be on April 26th. I'll be sure to send you an email invite. If you have any further questions, we can take it offline, but we thank you for your time and joining us today. And thank you, Sudhindra and Daniel. We appreciate your time in supporting
Thank
us
you.
on this activity.